chips, cache management techniques, and non-volatile memories for large multi-core systems. He is the principal investigator for SERB ECRA and MHRD Spark projects. He is having active research collaboration with the University of Catania, Italy, University of Essex, UK, University of Florida, USA, and Federal University Naples, Italy. And he has given many technical presentation in various international conferences held at Brazil, UAE, Singapore, France, Italy, South Korea, and USA in the fields of computer design, interconnection network, and design automation. He has many international IEEE and ACM peer-reviewed conference publication and ACM and IEEE transaction journal papers to his credit. He is the recipient of ACM CIGDA, IEEE CEDA, IAC, and DRDO research grants for research presentations held in various international venues. So we have a very eminent personality for this session. I extend a warm welcome to Dr. John Jones. Over to you, sir.
Thank you, madam, for the introduction. On the outset, let me thank the organizers of the ATAL FDP program on Internet of Things, organized by LBS College of Engineering, Kasaragod, for giving me an opportunity to be along with you as a resource person. When my old friend, Professor Sorensi, invited me for this FDP, I was very happy to accept the invitation. Because this is an area which is very close to my research domain, not only purely in the IoT domain, but as well as improving the infrastructural requirement for computing for the IoT sector. So in this regard, next 1 hour to 1 hour 15 minutes, I would be sharing mostly on autonomous vehicles or the next generation vehicles, and how can IoT specialist, architectural specialist, and communication specialist can contribute to India's self-reliance capacity in building India's own autonomous vehicles. So I will be using my slides towards the end of the talk. I will share these slides with the coordinator. You can use them for your future reference. Let me share the screen. Can someone update whether can you see the screen or not?
Yes, sir.
Okay. So I request the coordinators to please call me in between if at all there is any technical issue by which the connection got so disconnect. While delivering the talk, sometimes the speaker may not so recognize whether is there any technical issue in between or not. That is a problem with sometimes online learning. I hope everything will go fine.
Sure, sir.
The title of my talk is Next Generation. The title of my talk is Next Generation Vehicles, Challenges and Opportunities. So this is going to be the rough outline of my talk. I will introduce about the concept of Internet of Things, which I hope in the last two days of the FDP, many speakers might have already touched upon. So that makes my task little easy. And then I will pitch into the role and scope of IoT and the concept of autonomous vehicles and different levels of automation. And then I talk about architecture of autonomous vehicles and what are the communication challenges in it. And then, since artificial intelligence and machine learning are something that are going to intrude into every other sphere of computing and electronics, we cannot even set apart them also in the case of autonomous vehicles. So what is the role and scope of artificial intelligence and machine learning concepts that can be embedded into the future autonomous vehicles, and how will AI and ML drastically change the terrain of IoT? I'll talk about future cars, how cars are moving from automobile sector more into an electronic sector, and then I will conclude my talk. I have kept apart 10 to 15 minutes at the end for a Q&A session also, such that I can clarify if at all any queries the audience have. This might have been the slide which all other speakers, those who talked before me, might have started with. What is IoT? As you all know, it is connecting various devices over the network and try to control, coordinate, collaborate across the network. That is what is known as Internet of Things. Now, we already know that our transformation of our life has happened a lot, especially during this pandemic time also. The contribution played by IoT was very much significant. Some of you might have aware that yesterday the vaccines have been delivered to 13 important cities in the country, and those who have listened to the news yesterday and the newspapers today morning might have seen that the power of IoT in tracking, coordinating, and secure delivery of the COVID vaccines all over our country. It involves a lot of sensing, whether the containers that are being shipping with the vaccines have traveled to the corresponding destinations. Then security is being involved. Only designated officers can open it using their biometric. And every 3 seconds, these containers are being tracked. So everywhere there is going to be a precise kind of a coordination that happens. Like that, every IoT device that is being connected, if you look into an IoT compute infrastructure, then there is going to be a lot of sensing that is being involved. So you need to get data from the surroundings. It can be by manual intervention, or it can be automatically collected with the help of sophisticated sensors. So you require precise perception of the analog and human environment is required if you wanted to send some data. And whatever data that you have collected, it need to be send it across through the network. So then that involves connectivity. You need to have good and reliable internet in order to send these data. So you have close to 1 billion devices that are already being connected. And if you look into that, whatever data that you sensed and send it across the network, it need to be processed. And in order to process this huge amount of data, we require sophisticated algorithms, automated algorithms, and sometimes we may have to use powerful microprocessors and clouds in order to process this data quickly. And then overall, this entire sensing, connectivity, and processing need to be carried out under the safety and security mechanisms, because this data is traveling through an unreliable network. So we always need safety and security for all the data, physical and functional safety and security to protect the smarter world. The IoT growth is very much visible. When we studied for undergraduate programs 2 decades before, the maximum level of automation that a common man can experience is all about connected consumer. We started using ATM cards, and then we can make mobile payments sometime. So that is the way how things were being 2 decades before. From mobile payment with smart cards, with wearable healthcare, we moved to smart homes where many of the appliances and computings are being done. Smart metering are there, home automation and the surveillance, everything were. And then we moved to smart transportation. Some of our cities have smart and green mobility mechanisms, autonomous transport, traffic management, plus infotainment. Everything have been looking into the smart way. Then we have smart cities, where smart retail management, public safety, the identification, secure identification, smart access, something like your fast tag that you have in your car, then smart infrastructure in hospitals. If you go, you have wearable gadgets by which a lot of your body parameters are being sensed and it is being transmitted to the appropriate doctors and nursing care support. Smart transportation. Nowadays, we can know where the vehicle is. When you fly, you can know the flight travel history. The trains you can track. So there are a lot of devices that are being connected across internet and then from reliable data that is being supported. We are moving to smart industry as well, where a lot of automation happens in the factory sector. And being one of the largest agricultural produce exporting country, our agriculture is also moving into smart utilities. You might have heard about many examples where you can relate IoT concepts. What if your vehicle could talk to your home IoT? What if your home could talk to your car? Let's say you are going to reach back your home from your office. Consider it to be a bright, sunny, hot day, especially the tropical climate. Before reaching home, what if you wanted to turn on the air conditioner in your home? The thermostat can be controlled from your mobile phone, from your car. That's the way how your car is going to be connected across internet to your home gadgets. Before reaching home, let's say if you have a villa or a home where there is a gate, by the time you reach close to that, you can keep the gate open, or else someone has to come and open the gate. So that is the way how which vehicle is connected to your home automation system. What if your body could talk to doctors? What if you can have a microscopic chip that you swallow, records your biorhythms and health statistics, and when you need health care, it sends you quickly data directly to your doctor and give you a dose of your life-saving medication from a small patch on your arm, maybe a small tiny chip, and calls for help like that. India is a country where we have a lot of people who have been affected with diabetics and chronic diseases related to cholesterol. These are diseases mostly that happens over the lifestyle by having food which are more oily in nature and lack of exercises. We have heard of a lot of people who lose their lives due to cardiac arrest. And we know that cardiac arrest happens, majority of the cardiac arrest happens because of blocking inside your blood vessels. And this blocking is not happening with just one day. It may be happening across multiple days of accumulation of fatty materials inside the blood vessels. Looking further into this domain, what if you could integrate a small biochip such that it is in contact with your veins or arteries, which could regularly monitor your blood cholesterol levels, the blood sugar levels, and can give necessary warnings to you or your near ones or to your family doctor, such that you can get a warning maybe in your mobile phone down the line. Like if you continue your habits like this, maybe in another 1 or 2 years, you may have chronic problems. So such that so many of the sudden deaths that happens due to heart problem is because of lack of thorough testing. Sometimes we may feel very much healthy, okay, and we continue with our day-to-day work. But sometimes there may be minor problems inside our blood vessels that can lead to sudden cardiac issues. So if we have the leverage of technology that can be used in this way, such that there is so going to be some kind of a sensing that is being fitted inside your body, all the way it is going to communicate to outside world, and then you can give necessary warnings. In future, because those of you who are having family members who have diabetics, one of the problem with the diabetic patients is sometimes if the food level is not matching with the dosage of medicine that you take, then it can lead to problems related to blood sugar level going up or down. One scenario is sometimes blood sugar will go down and then you may feel dizzy and uneasiness. What if you get a message in your WhatsApp telling that, hey, John, in another 30 minutes, your blood sugar level is going to come down. You need to take some sugar or some fruits or some sweets soon. How can that be possible? If there is a continuous checking of your blood sugar level, and based upon that, if you could get warnings like this, such that if you go like this, if you're not going to take a food, then in another 30 minutes, your blood sugar level will go below a threshold, and that's going to be a problem. So in future, just like we have vaccination charts, in future we may have a set of small chips that has to be implanted in the body. Nowadays, when kids are born, we get a vaccination chart at so and so months, so and so years, you need to take vaccinations. Now, if you look at that, I'm sure that the world is going to grow in such a way that we may have to implant a lot of chips, biologically inert chips, but then they will be capturing vital statistics and give us necessary warnings. These are all some of the motivation levels for IoT, body to outside the body. Our today's focus is more on vehicles. What if your car could talk to another cars? Let's say a driver in one side of the road finds that someone else in the other side of the road, if the driver is a little sleepy or he's drifting away from the line, he could press some buttons and give warnings to you. What if inside your car there is going to be some kind of a sensors? These sensors are going to be measuring some information, and I can have someone who's securely monitoring me from a distance, and from there they are going to give me some inputs such that I can continue my journey in a more secure way. Think of a case that the car, the infotainment system, once it knows that you are going to drive alone, once in a while, if it is going to ask you some questions, and if you are not going to give proper answers to them, then you may be considered, because the system may be considering you it as like you are not alert or you may be sleeping. Then the control system may give you necessary input such that you can be given a small shock near the seat. You may get a pinching feeling such that you can come back. Or someone else may be remotely monitoring you and they can actually control these things. Let's say while I am driving alone, maybe 3 or 4 hours of drive, and if there is a small control of my car to my wife who is sitting at home, once in a while there can be some questions, and if the car IoT mechanism find out some kind of an anomaly where I am not concentrating or I may feel sleepish, I can, the car system can give the messages to my wife, and then wife can press a button, and by virtue of it she may be able to control the car or reduce the speed of the car or call me, something like that. Like that, accidents can be saved. Before I continue further, I request the coordinators. Sometimes I'm getting a low internet connection or stability issue. Do you find any problem in hearing, or do I need to switch the network? Can someone from organizers to get back? Is everything going fine?
Yes, sir.
So is there any clarity issue or sound not able to get properly? Okay, thank you. So we all know that vehicles and journeys are part and parcel of our day-to-day life. We need to travel for work and for leisure. Especially in 2020, this may not be true, but then we are all coming back to our leisure trips and travels. And during normally this time, the driver's job is little tedious because all other family members, when they travel, they may enjoy, and driver need to concentrate on the road and the traffic. These are going to be bedtime stories. Even the driving license will become like a floppy disk in the future. I doubt some of the audience might not have seen a floppy disk ever in their life. Maybe people who belong to my age group, close to 40, we are the last ones or last generation who could see a floppy disk. If you wanted to see a floppy disk, you may have to visit a museum. Like that, driving licenses are also going to be part of history. They'll become part of bedtime stories. You can tell your kids and grandkids, like 50 years before, if at all you wanted to drive a vehicle, then someone has to sit and drive, and then you need a driving license. You need to take 8 and H, and vehicle inspectors will inspect and give you license, something like that. Or you will tell about stories of bribing people to get a license. Future cars won't have drivers at all. How are we getting onto such a kind of a scenario? Already driverless cars are there. In some of the most modern countries, we have driverless cars already there. Let us try to understand the driverless cars and what are the contributions that future engineers need to put in order to make driverless cars a reality in a country like India also. When I specifically tell India, here you all know that the kind of effort that is required for a driver in driving a road with well-defined rules and regulations being followed by the motorists as well as the pedestrians. Considering to the scenario, like if you go to a crowded city like Chennai or Bangalore or Delhi in India, how chaotic is the driving? So how will driverless cars emerge into the Indian market? So the Indian challenges to the driverless cars, if you look into, we have Indian roads something like this. And how will an automated car work in this kind of a scenario where others are not following rules? Even if you are perfect, what if others are not following rules? The kind of algorithms that is being written there could not actually bend properly. There can be scenarios like this. We have unsolicited guests sometimes on the road, which is also a strange scenario of the Indian context. A rich democracy that we have, sometimes then democratic protests happen inside the roads. Think about automated cars trying to handle these kind of unexpected scenarios. And then we have very smart Indian pedestrians who make use of roads also for talking with their friends or family relatives. A special disclaimer, these images given above are only for scientific understanding of the challenges in driverless cars. I would never intend to disregard any political party or religious belief of human habits. Strictly from the engineering perspective, from the science perspective, I have put in. Sometimes some of you may feel that, okay, this is against my favorite party or my belief and all. Why are road accidents happening? Studies shows that there are 1.3 million road traffic deaths occur every year globally. And it shows that if someone is hit by a vehicle traveling at 35 kilometers per hour and then they are going to hit, then 9 out of 10 pedestrians will be surviving, but one may be dead. If the speed increases to 50 kilometers per hour, the same scenario happens. 5 out of 10 will survive, and if the speed is at 70 kilometers per hour, then only one is going to survive. So speed is something, and then we are all looking to reach the destination as quickly as possible. So out of accidents that happens globally, 90% are caused by human errors. It can be the pedestrian error, it can be due to the driver, it can be due to someone. Only 10% are caused by machines. Now look at the right side pie chart. Out of the accidents happens, 78% of accidents are happening due to the fault of a driver. And then we have a reasonable significant percentage of 2 to 3% happen due to the fault of a pedestrians. 1% to 2% because of fault of the road. Sometimes defective vehicle conditions are there, and there can be some other reasons as well. If you look into all the driver related accidents, 78% if you try to extrapolate, try to dig deeper into that, then you could see that close to 40% of the accidents caused by drivers, they are due to recognition errors. What do you mean by recognition error? When I wanted to travel, when I am driving a car, let us say a dog is going to quickly cross. I couldn't recognize it as a dog. I couldn't see it. So then what happens? I am not going to apply brake or something. Or I recognize it's very late, then suddenly I apply brake, and that due to line changing or someone is going to hit me. I saw that it was a turning. I couldn't see that. I thought that there is a hump, but there was no hump. So I reduced the speed all of a sudden, or vice versa. Now, if you look at the red portion, that is close to 33 to 34% is happened due to decision error. Driver made a decision, but that decision proved to be wrong. How can that happen? For example, let's say I wanted to overtake. I thought opposite there is a bus coming, but I thought I can cross it. I thought that the speed of the bus that is approaching me in the opposite track is less, such that before the bus reaches my position, I could easily overtake the truck which is in front of me. But that decision was wrong. I thought there is a bend. So at that point, I need to reduce the speed to 50 from the currently 80 kilometers per hour. But reducing to 50 was not enough. I should have reduced to 30 or 20. That's a decision error. So it is very easy for us to understand what do you mean by recognition error and what do you mean by decision error because of the recognition and decision making capability of a driver, which will lead to accidents. This is the majority chunk. There is something else known as performance error, which comes close to 10% of driver's fault that will lead into accidents. Let us try to understand what is performance error. Think of a case that you had a long journey. Let's say you are a doctor, you had a night duty. After 12 hours of duty in the hospital, you are going to drive back to your home, which is 1 hour drive. So whole night where you are supposed to sleep, you are doing your work. And then again you are driving and you are driving alone. You may feel sleepy because you are not in the right performance index at that point. Let's say you are having long drive for 12 to 13 hours, you are driving, even though with short breaks, and then you are traveling. People who wanted to travel long distance, sometimes they may drive in the night due to reduction of traffic. And the drivers have some fatigue. Morning also they are driving, night also they are driving. So that can lead to some kind of a carelessness. It is not because of decision error or recognition error. It's because they get sleepy. So it's known as performance error because of the driver is not able to focus its attention or getting sleepy. If you look into the green portion, that comes to 5 to 6%, that is something known as non-performance error. What do you mean by non-performance error? Non-performance error means, think of a case that you had a quarrel with respect to or with your family members, or think of a case you had a quarrel with your wife or husband, spouse, and it went for 1 hour and then you are driving back. And then you felt today, it is, my God, there is a lot of problems. I had a quarrel with my kids, or you bit your kid. Because of your anger, you slapped your small son or daughter, and then later while driving, you feel bad, and then you feel uneasy, and you are not able to concentrate. You had an argument with your colleague. And because of that, your lack of attention, your mind is disturbed, and this can lead to accidents. We call that as non-performance error, and there can be other issues as well, which all sum up to another 8%. So if you look into that, due to the fault of driver, there can be recognition error, decision error, performance error, or non-performance error. Now, when you replace a driver with an automated system with the help of sophisticated IoT, then there won't be any recognition error, or the margin of recognition error will be drastically come down, because machines, once it is trained well, and then it is going to give you proper recognition. It will take the right decisions. It will recognize the right events. So recognition and decision errors are going to become close to less than 5%. So if there is a decision error that happens in a driverless car, and then obviously the architects will find it out, and then they will also add that particular case such that all the future cars will not make such a kind of an error. And the beauty is, once if I learn as a driver, it cannot be transferred to my wife or my siblings. Whatever I learn as a driver, it is my own experience. But when you replace a driver with an automated system, every automated system is learning from their mistakes. So it's a learning car. I thought there is a dog crossing, so I never recognize it as a door. So imagine your automated system could not recognize a dog that is crossing, but that led to an accident. Then such cases are also added into the learning curve, and I will learn from my mistakes. Next time such a kind of a similar scenario happens, I will recognize it as a dog. So like that, and whatever intelligence I have accumulated, I could transfer to my other cars of my same manufacturing company. So it's called a collective learning. That's also a great important thing. So if you replace a driver with an automated system, then that is surely going to help us a lot. Then these kind of errors will never happen. I'm sure that performance error, a machine will never complain. I've been driving for the last 10 hours. I need rest. Such a kind of a scenario will never happen. And machines don't have spouses. Machines don't have lovers. They don't have parents. There is no question of quarrel related issue, mental peace, mindset. Such kind of non-performance errors will not happen. So is replacing humans with robot on wheels a solution? Now our cars are vehicles. Future, we may have to call our vehicles as robots. 20 years before, we could never thought of we could have such kind of online meetings to deliver talks. We should never thought of having powerful gadgets in our hand by which I can connect to any place in the world. Checking mails, watching movies, playing games, everything is now possible. So 20 years is quite a short period. Within this short period, each and every person in this country now could afford a 4G network connected phone, access to internet, and then do commercial operations, economic transactions, banking transactions, accessing classes, searching on the net. Many things are possible. So in another 10 years down the line, you may not even bother much about how do you drive a car. You may have to click on the appropriate button and the car will take you all the way. Recently, I have renewed my driving license, and then the vehicle inspector asked, "You are taking it for 10 years or 15 years?" I was just laughing at me inside. I thought that maybe in 2035, I need not renew my driving license at all. If at all I am alive, probably by the time driverless cars would be there. So that is going to be the story. Now, if you look at the Society of Automotive Engineers, abbreviated as SAE, there are different levels of automation. Let me take you across all these levels in order to understand the basics of driverless cars. We are now having level 0 automation. Basically, it is no automation. Complete driver is controlling, which is called it as zero autonomy. The driver perform all the tasks. We can see from the left side diagram, the hand of the driver is touching the steering. The legs are going to be used in the pedals, clutch, accelerator, and the brake. And his eyes and ears are alert. Now, if you move to level 1 automation, we call it as driver assistant. The vehicle is controlled by the driver, but some driving assist features may be included in the vehicle design, something like cruise control. Let's say I wanted to reach at 50 km per hour. I can press on a button. I can remove my legs. I should not put acceleration. So the vehicle will continue in 50 km per hour. And when I touch the button once again, then the driver may have to use it. So I need not always use my legs. That is called one example of a level of automation. So what happens? What is the engineering behind it? If you look into that, when you press the button, whatever was the speed, record the speed and the effect that is being created by pressing the accelerator, let's say at 50 km per hour, it need to be continued. So there is no need to further pressing. I have to record. I have to recreate the same activity. So there is a little bit of electronics also that has been involved there. Now, if you look into the next aspect of it, that is called partial automation. We call it as level 2 automation. The vehicle has combined automated functions like acceleration and steering also is now under the artificial intelligence. But the driver must remain engaged with the driving task and monitor the environment. So I can take off my hand also. So we call it as hands off. Whereas in the level 1, it is going to be hands are on, eyes are on, but legs are off. Here hands can be temporarily off. Let's say when in highway, minor corrections of line adjustment, tilting of the steering, everything will be taken care of. You may be thinking, what is the scope of IoT in it? There are a lot of sensors that are being connected. There are cameras. Now, whatever you see, and how do you change the steering wheel? Looking at the images that you get, you know there is a bend, you know there is going to be a turning, there is going to be a signal. All these what you conceive in your mind, it has to be done with the help of a machine. So there are a lot of sensors that are being there in different parts of the vehicle. And sometimes you may get input from the roadside units, from other vehicles, from the app that is being connected to the central monitoring station of the vehicle controller, many other things. And then this has to be sent to a place where you process it, and then appropriately the steering wheel has to be adjusted, acceleration has to be given. Like that, I can increase or decrease your speed. Now you move to conditional automation, that is level 3. So the first 3 level 0, level 1, and level 2, driver monitors the driving environment and little bit of automation is being done. Now we are moving into more to IoT. You are going to connect things, and what are your things? There are a lot of sensors. The sensed data has to be communicated to a processing place. So you require high-end connectivity, you require precise sensors, and you require faster processing in order to process this data and take appropriate actions. Let us try to understand level 3. We call it as hands off and eyes off. Driver is a necessity, but it is not required to monitor the environment in the case of level 3. The driver must be ready to take the control of the vehicle at all times. So here we can say that your hands are off, your eyes are off, and then the vehicle may give you some kind of a warning. Once in a while, you can look at, and the vehicle give you some warning. At that time, you may have to take the control. So whenever the vehicle feels something out of their capability, it will indicate the driver. So that is the next level of automation. Moving into high automation, that is known as level 4, the vehicle is capable of performing all driving functions under certain conditions. The driver may have the option to control the vehicle. So your hand is off and your mind is also off. That's the kind of setup that we have now. What do you mean by that? Hand is off and mind is off. The driver can do many other things. If it is needed, then the vehicle may wake you up. So you can completely relax. But still the driver is required at a time, then driver can take the control. Now, when it comes to the full automation, that is called the vehicle is capable of performing all driving functions under all conditions. The driver may have the option to control the vehicle if needed, but driver is not required. That's why you can see that in level 5, there is no driver present there. Actually, there is no steering, no clutch, nothing, no driver features. So when you move to level 2 to level 3, we started trusting more the automated driving system monitors the driving environment. So we are now into the world of connected vehicles, or we are going to head into the world of connected vehicles, where you can see that there are a lot of roadside units, maybe the electric poles, the street lights, and then vehicles itself are connected. There are a lot of sensors inside the vehicle that are being connected by a local canvas. Vehicle itself is connected to the cloud, which will give you necessary warnings and indicators. Vehicles has to be registered under the Road Transport Authority, and if needed, they can disable the vehicle if some of you are violators. That means nobody can do any unlawful activity can escape. So some kind of a controlling it is there. So that is going to head into like people or the regulator can actually control the vehicle when if it is required with the proper necessary warnings. Now, how to build future cars? The architecture of our future cars, we call it as basically brain on 4 wheels. They have basically 3 components. First one is known as a sensing unit, a thinking unit, and an acting unit. Consider the case of an example. A car is going to hit another car if you go like this. So I sense that the relative distance between me and an opposite side car is going to be less than a threshold. So I understand that. That's called thinking. So sense, I find out the distance. Thinking, I compare the distance with the threshold. And then I take a decision that I cannot go like this. I have to change the line. So I act accordingly. The steering wheel is adjusted. So in a sensing, I will sense the environment. I make decisions based on environment and I carry out decisions. So if you look into the future of cars, we need people who are expert in sensor system technologies. That comes to more to electronic side of it. The second portion is we need cars that can take decisions based upon the sensed data. That is more of computer science, more of algorithms, programming, and embedded systems. And we need, based upon the decisions made, we need the appropriate circuitry to activate the appropriate units inside the car. So the units are going to be more of automobile in nature, but rather than manual intervention, it is going to be electronic signals or waves or electromagnetic waves that are going to actuate your engines, your other units that are going to control the car. So from electronics to computer science to automobile, future cars are going to be a cross-disciplinary equipment, a cross-disciplinary gadget, which has all these components in it. If you look at the architecture of driverless cars, we can broadly divide them into 5. First of all, you need to have a connectivity domain. There are a lot of data that is been there, that is being generated from near the vehicle, from inside the vehicle, that are being pumped from the cloud, that are being shared by others who traveled in the same route, that are being shared from other applications which will help you the car. So there is a connectivity domain that has been involved. You need to understand what are the kind of signals that are to be used. where we use wired connection, where we use wireless connection. When my car is going to be getting connected to the GPS, at the same time my car is going to be getting connected with the camera that is been fitted on the backside. How can I integrate both of them together? What kind of frequency? How will I make sure that is not there? So that is all known as the connectivity domain. The second one is known as the driver replacement domain, because you are going to replace drivers with embedded system, with embedded intelligence. How do you do that? You require cameras, you require radars, you require lidars. So what are the gadgets that are to be used? And then you have the powertrain and vehicle dynamics domain, which will manipulate your speed, your pressure, your wipers, and many other things. And then you have the body and comfort domain, whether there are any sensors near to the door, and many other vehicle parameters, how do you display, and then you have the driver experience, the infotainment, the announcement system, the display unit. From luxury to comfort to security to connectivity to drivers help, all the things are being involved in the case of an architecture of a driverless cars. Let us now think more of the topic of the FDP, wherein the FDP discuss more about the IoT aspect, the connectivity aspect. Now we know that there is a sensing side, there is a thinking side, there is an acting side for a driverless car or an autonomous car. And then if you look at the broadly 5 domains, because the future of our country has to embrace autonomous cars. India is a country where even during the lockdown time also people were buying vehicles because they cannot travel more in the public transport because of fear factor and maintaining social distance. But in automobile sector, at least in two-wheelers and some low-end cars, they still were able to manage to some decent level. Now it's picking up. And have you ever thought of what could be the hardware unit? What could be the microprocessor that handles? So we need experts, domain experts in microprocessor units. So those of who are faculty members or researchers, you may have to sensitize your students that in the next 10 years, there is huge demand for electronics, computer science, and communication engineers in building India's driverless cars. Each and every company, let's say Hyundai, Tata, Maruti, everyone is investing in R&D for realizing autonomous cars for Indian roads. Previously, they were recruiting mostly people from mechanical, automobile, and electrical domain. Now they started recruiting people from electronics, computer science, and mere programming domain. So we need, if someone is expert in computer architecture or microprocessors, they have a scope, because ultimately the data has to be processed by a powerful hardware unit. So you need domain experts in microprocessor units. Then there are a lot of sensors and nodes that are being connected. So you need experts from the edge nodes and sensors. You need experts in communication specialists with high bandwidth communication. We need communication engineers. So those who are doing communication and engineering related masters or research work, very good scope for you also in this domain. You need people who work in the gateway, because there are different kind of networks inside a car, from cellular to Wi-Fi to near frequency communication, like that. And overall, we require people who work in safety and security domain. So if you look into that, almost more, lot many fields of computer science and electronics are integrated along with the automobile sector, is integrated into the future autonomous cars. If you look into the connectivity domain, what are the aspects you need to think when you come to sensing? We need cellular communication. Sometimes you may communicate using 4G and 5G. You need Wi-Fi connectivity such that when you reach a city, the nearby every traffic pole may be a Wi-Fi access point and you have to connect. Sometimes for other small sensors within the car, you require Bluetooth sensitivity. Let's say the driver is going to enter into the car after drunk. The car may not even start. So there can be some breath analyzer which is connected in Bluetooth fashion to the engine. And if the breath analyzer is telling that alcohol content in the exhaled air by the driver is above a threshold, it is not safe. We need to have near frequency communication. We need to have smart car access, because in the key, once the key is near, then only the door should be opening. So in the connectivity sector also, we need a connectivity domain controller. We need microprocessors which will coordinate the data that is being received by these connectivity components. Then when we come to automated driver assistance systems and autonomy, we require vehicle to vehicle communication, vehicle to infrastructure communication, vehicle to satellite communication. We require radars, we require cameras, we require lidars, and how are we going to store the data? So you require sensor fusion and planning domain controller in the thinking side. Coming to powertrain and vehicle dynamics, motion and pressure has to be checked, the speed of the car has to be checked, ultrasonic facility has to be connected, and that will connect to the powertrain domain controller. We require separate microprocessor to handle connectivity, to handle autonomous driving, to handle powertrain and vehicle dynamics. And in the powertrain and vehicle dynamics, sometimes based upon the input, you may have to act also. So it need to be connected to the engine, to the steering, to the airbag, to the transmission, to the braking system, to suspension, to battery and cell management. Coming to the body and comfort zone, we may have to go for temperature, lighting inside and outside car, humidity check, the switch panels, and based upon that, what are the activities that is happening, interior lighting, doors opening, the glass sliding up or down, windshield, wipers, sunroof, many things, mirrors has to be adjusted. So they all come under the body and the comfort zone. And overall, you need to connect to outside world. You need to have display units and sound systems. You need radio and audio facilities. You require touch displays. You require voice recognition. So in future cars, you can tell a lot of things. I want a song of Lata Mangeshkar. Just tell that and the song will be played. Something like how you use the Alexa. So you require e-cockpit domain controller also. You require amplifiers and e-clock links. So if you look into all these sectors based upon your interest, you can concentrate on the sensing side. Or if you are an expert in any of these components that I described in the sensing side, then you have or your students have a good role to play in future cars of the country. If you work in the thinking domain, if you work in the acting domain also. So from electronics dominated sensing to the computer science dominated thinking to the automobile sector dominated acting, there are a lot many different streams of engineering that are put together in order to realize autonomous cars. If you look into further the sense infrastructure, now you have to think of how these devices are being connected. After getting signals from the radars, from the cameras, from the lidars, from the maps and localization, from the vehicle to other component communication and all, you need to connect them. So since there are different kind of sensors and different kind of data that is coming, the frequency of the data, the pattern of the data, you require separate connectivity channel. And this is basically a very complex IoT that you are seeing. It's an internet of sensors that is being connected together. Now, this diagram is rich in lot of information. What you see on the front left side is you requires cameras that will help us in adaptive cruise control for long distance. You require emergency braking, pedestrian detection, and collision avoidance mechanism. So there need to be some kind of a camera that has to be fitted on the top of the car, which has to understand these kind of scenarios and take appropriate actions. Sometimes you need to recognize traffic sign recognition, whether it's going to be a stop or the reduction of speed, red light, traffic lights, line departure warning. I may move from one track to another when my speed is going to change. So first of all, I have to see in the nearby track anyone is coming or not. Whatever a driver is doing, we look at the mirror and then take a decision. Should I take the right or left? Is it safe? Cross traffic alert. So you require long range radar in order to carry out some of these operations. Sometimes you require ultrasound, which will take care of the adaptive cruise control, emergency braking, pedestrian detection. You require lidars for collision avoidance. You require cameras for lane departure warning and traffic line recognition. Then you require cross traffic alert with the help of long range radars. Sometimes you require surround view. Some portions we cannot see directly using that. So you require sensors there also that we use short range radars. We have blind spot detection, rear collision warning, park assistance and surround view, wireless communications. Many things are required ultimately in order to handle this. So being architects, there are a lot of things that electronics people or computer science people has to play in the design of a future car. What kind of frequency, what kind of communication, what kind of electromagnetic waves are to be used, what should be the bandwidth, and how can I ensure fault tolerance? What if someone gets damaged? What if the long range radar get damaged while traveling? Suddenly the driverless cars becomes ultimately a problem. You require high performance sensing, that's what I told, precise recognition of the analog and human environment. Sometimes you require beyond line of sight communication. Sometimes radars, lasers, vision, and ultrasound signal will help us for line of sight communication. Sometimes you require human contact. You need to recognize whether someone crossing is a human being or not, or it's a vehicle or not. Are they really moving? So while you are driving, someone is running. So you have to anticipate by the time you reach that person, will he completely cross the road, or with his speed, will he be able to reach halfway? So you as a driver know when someone cross the road very slowly, you know that he will not reach or he will not complete crossing. Someone is running quickly, but it's okay. By the time you reach, he has completely crossing. So you are kind of an anticipating based upon the trajectory, based upon the speed of the movement, you are going to take a call whether should you brake or not. And that is happening within nanoseconds. Similarly, you require face and gesture recognition, biometric sometimes, voice recognition, many other things are being required. Think of a case that while you reach a junction, you can see a traffic light with a red color. That means you have to stop. What if such a kind of a similar red circle is being placed in an advertisement board while traveling? So you know that one is a traffic light from its surroundings, and the other one is just similar to traffic light. What if there is a traffic light diagram or a picture or a drawing that is kept in a hoarding, an advertisement hoarding? What if there is a traffic light symbol on the backside of a bus as a fancy drawing? So your car system, the sensing system and the processing system should understand one is a painting and the other one is a real traffic light. It's a very, very tedious task. Now, after the system is been fitted, there may be newer drawings, newer kind of confusions that can come. New scenarios may exist. So just like your software upgradation, every morning, just like their antivirus upgradation, newer inputs, newer accidents that are being closed, and the learning that the machine had in one part of the world may be shared with all other softwares that are helping us in driving. So it's altogether going to be a very important kind of a scenario. And it's going to be very interesting as well. And as long as human beings are there, vehicles would be there. Now the connectivity, then infrastructure, if you look into, sometimes we require ultra short range communication from your phone to the infotainment system, from the key to the steering wheel, from the breath analyzer to this. From someone sitting on the back, they will tell increase the AC temperature or reduce. So ultra short range communication like Bluetooth, Miglo, the NFC, this can be used. For short range communication, sometimes you may use Zigbee, Wi-Fi signal, ultra wideband signal. Sometimes you may need to communicate to far off from the car. You may have to communicate to the satellites. You may have to communicate to the roadside infrastructure, to the mobile phone tower. So you can use Sigfox, LoRa, 5G, LTE, like that. So connectivity landscape with varying performance, energy ranges are there. The people who work in the communication sector also have a lot of scope in this. Now let us come to what is the role of artificial intelligence and machine learning techniques in this. You look at the scenario. These are the things that a driver will see and driver will understand. On the left side picture, there is a truck and there is a car, there is a CCTV that is kept, there is a traffic light and the colors. Sometimes you may have to detect the objects. There is a bus, there is a car, there is a person, there is a hand lock. Now, even if a person, sometimes in the winter, a person may be wearing a monkey cap or a cover or a shawl, so you cannot recognize the face. So looking into it is winter time. Sometimes it may not be always possible to recognize people when there is snow. So if your car system is always learning in such a way that road means black color. It need not be. Sometimes it can be muddy roads. So there should be always a case that, so when you move from a tropical climate place into a snowy area where you are going for a hill station visit, there can be possibility of snow. So when the snow is there on the side of the road, it should not be considered it as some other object, or appropriate software has to be self downloaded when you move from one terrain to another. When you move from a well maintained national highway into a village ghat road, off road driving, then appropriate software has to be updated. Now if you look at the diagram, you need to recognize objects. So it is like a computer vision has an important role here. So you might have heard about graphics, and some of you might have heard about vision problem also. So graphics research as well as vision research are also important. Now, what is the difference between the two? Graphics means when I tell the center of the sphere is this, and this is the radius, drawing that sphere there, that is what is known as graphics. So given the dimensions of an object, drawing the object is a graphics problem. Now, given a ball, you are saying that there is a ball in the image, and it is telling that the center of the ball is at so and so place, and the radius is this much. That is a vision problem. So extracting the characteristics of an object is a vision problem. Given the characteristics of an object, display the object is known as a graphics problem. So you require mono cameras, which will be helpful for lane detector and traffic sign detector. So you need to be expert in 2D object detection. Sometimes you may use radars to point data and relative velocity. We may use lidars to point cloud data, stereo cameras. So you are using object detector mechanism, 3D object. You have to find out, let's say I'm going to cross a vehicle. You have to find out how long it is, whether it's a normal truck or a long truck, which is having extra length, 20 tires. So automated sensor fusion engine has to be there. We have GPUs, wheel sensors, IMUs, global positioning system. So it's a vehicle state estimator, vehicle state information. So your occupancy grid map, your vehicle state information, environment map, all put in together for a guidance, navigation, and control. Now, what are the types of algorithms? If you look into the computer science perspective of it, you need to have very fast, quick response, lane departure warning algorithm when you move from one track to another. Sometimes when you drive also, there are certain blind spots. Even if you look at the mirror, certain things you cannot see. How do you manipulate blind spots? How do you detect pedestrians? How do you manage adaptive cruise control? How can you maintain the same speed? How do you manage forward collision warning? How do you take care of 3D imaging? How do you take care of depth detection? Edge detection. Once you are going to overtake a truck, you have to make sure that your car will not hit the edge of others. Motion detection, tracking algorithm. There is a car that is going to come. You have to project the trajectory of the car such that by the time you reach, you will be there. What you see here on the left side, lot of sensed data. What you see here is a vision understanding. Whatever you see, based upon that, you may have to understand 3D objects, its depth, and many other parameters. So how it is all done, that's what you may have to look into. It's basically electronic data capture that I mentioned. And then you store this information in binary format. And then we require powerful microprocessors on which programs are run to look into anomaly of data or uniformity of data, and then give appropriate warning sometimes, or can control the car engines. What are the kind of compute infrastructure that you want in this kind of a setup? We have learned this. Sensing, thinking, and acting is required, powerful microprocessors. So we call it as basically, um, uh, this is a kind of then setup where you have a tiled chip multi-core processors that are there. And then in this case, it is going to be slightly difficult for you to coordinate all these using a conventional microprocessors. So you have a TCMP system, and then from the TCMP system, this is called tiled chip multi-core processors. There are lot many microprocessors integrated into a single chip, and each of these microprocessors will have a fetching, decoding, a branch predictor unit, a scheduler plus execution unit, L1, L2 caches. Everything has to be there, and this kind of a setup. So what are these? We have to understand this is the area in which I am working in multi-core processors required for supporting of IoT vehicles. In 2004, when processors and caches together form a chip which works on 90 nanometer technology, by 2017, whatever we fabricated 90 nanometer technology, I could squeeze them to 1/9 of its area. It's a close to 10 nanometer technology. 2017, we call it a system on chip. So that many processors and caches, I could integrate 9 such processor and cache in the available space. So consider the case that let's say you have a processor which has, let's say, 9 billion transistors available, and you are going to make one microprocessor using that. Let's say this much is the power and performance this bar chart shows. Rather than having one microprocessor, I can go for 1/9 of the transistors. So this is having 9 billion. Let's say I take only 1 billion transistors and realize a simple microprocessor. It will consume only 1/9 of power because the number of transistors are less. But performance is not really 1/9. Maybe it's still a microprocessor which can do certain tasks. So rather than going for a one supercomputer kind of thing with all the 9 billion transistors, I can make 9 simple microprocessors all integrated together in a single chip. I can give more performance to it. So multiple slower processors are preferred than a single fast powerful microprocessor. So it is these kind of multi-processors inside a same chip that are going to be used in the infrastructure for autonomous vehicles. So we have learned that there are a lot of data that is been coming. This data has to be processed. So one of the tile may be having a program that is running, and this program is going to be run based upon maybe a data that is getting from a camera. Second tile may have another program which will be running based upon the sensed data that is being shared by the back camera. Then from the sensor unit fitted on the road. Then the audio visual image that is screen that is connected. So you can think of many such kind of programs that are parallelly running. So it's a paradigm shift. Rather than conventional unique core processors, we need to prefer multiple slower processors is better than single fast powerful processor. So we use tiled chip multi-core processors for this design. This is you might have heard about dual core, quad core, and all. So in future we require 16 core processors or 25 core processors all in a single chip. So what you see here is the diagram of a 16 core tiled chip multi-core processors, because the processors are organized in a tiled fashion. And this PE is known as processing element, which consists of your registers, your control logic, your fetching unit, branch prediction, your decode, your issue, your out of order scheduler, your execution unit, your data load and store unit, your caches, L1 cache, your L2 cache, like that. And these processing units are connected with the help of routers. And we see these are going to be units which act as the communication infrastructure inside a chip, where each router is connected to other 4 neighboring routers. So we have a small network inside a chip. So this will be the compute engine of autonomous cars. And each router will get the data in forms of packets. So rather than bus-based communication inside a chip, we have a packet switched network inside a chip from one unit to another. And the routers are connected to east, west, north, and south neighbors, and one to the local processing elements. So we have data coming from various directions, and this data will sit in buffers. We call it as virtual channels. And then there is a crossbar such that these data, because it's basically a junction, so this data will move to the other alternate directions. And then this will be controlled with the help of a control logic. So processors with AI and IoT support are already there in the market. AMD processors, Google TPUs, the NVIDIA Pascal and Voltas, then Qualcomm's Snapdragon processor, then FPGAs of Intel and Xilinx, the NVIDIA's Jetsons, the NVIDIA drives, then Intel Xeon Phi processor, which is having 64 tiles, the NVIDIA Tesla GPUs, Google TPUs. So they all, even the hardware manufacturing companies are extensively involved in automobile sector. Now let us look into the future cars. See, we know that we have a sense of habit when you go for socializing function parties or big functions. We always go and dress neatly, special party wear dress. It may be the different kind of a dress that we wear while you going for your normal routine job. So we will change our dress depending on the occasion. And if you are so rich, like the Ambanis, then you could change cars for each and every function. Going for work in your Tata Nano car and going for a marriage function, you go in your BMW like that. Because cars are costly. The future cars are going to be something like this. You have the engine of the car, the chassis, that is one type, and you could change the upper side based upon on-demand module you can fix. It can be shared. You can buy this. You can buy the upper portion. It may be very cheap because it's just like a small room with the chairs and other things. You can buy it. When you are going for a family trip, you can buy this. Let's say you are going for the leisure trip with only two people, then maybe two chairs and a bed that is required. Let's say you are going for a bachelor's party, it may be different one. You are going to take some things to buy something from the estate, then you can go kind of freezer kind of a material. So we could change whatever you want in the upper side. So just like the way how you change a shirt or a sari or a dress material, the upper side box can be changed easily. And the lower side has to be dealt in a different way. So what you see, bottom side, that is known as the intelligent chassis, that is going to be the new workhorse. It has all sensing, all the brain of the car is this. The other portion is only for the extra comfort. That is going to be the kind of future cars. So we have companies investing in automated cars. If you look into this, cars means then you look for BMW, then Audi, Volkswagen, Maruti, something like that. Toyota, Nissan, these are all automotive sector. Now, if you look into this, what is Microsoft doing in car business? What is Intel doing in automotive sector? What is Huawei doing in automotive sector? What is Tesla doing in automotive sector? So you can see that many of the electronic giants, many of the communication giants are also investing in automated cars. Now, automated cars are going to give us huge amount of data. A lot of cameras are there, and this all data are going to come together. In the last year, the average autonomous cars process close to 4,000 gigabytes of data per day, while the average internet user uses only 1.5 GB per day. That means the amount of data that is being produced by an autonomous car is roughly going to be equal to 2,600 internet users' data. This is going to be huge data. So you need, in order to data, what if rather than a mere camera, what if I have an intelligent camera? If everything goes fine, let's say I have a back camera and the car is going to the front. So the back camera is also going to sense the data. Rather than the camera acting it as a mere camera, can it sense and see, okay, everything normal. I should not send the data to microprocessor. I can discard the data very well. So can I add intelligence into the camera, the IoT camera that is being fitted at the rear end of the car? Conventional way is it will capture data and send. Now what you do is, rather than sending, it will process, quickly process. Is it relevant? If it is completely not relevant data, it is not going to change anything because the car is moving forward, it will discard the data. I can reduce the data. So rather than generating huge amount of data to be stored here and there, I could discard data if my camera is intelligent. Let's say I'm going in a highway and it's a night and there is nothing much collision that is going to happen. You are alone traveling. Let's say you're traveling through a Ghat road, not much possibility of any other collision because you are the sole lone traveler. Lot of data that is being for collision detection and many other things can be discarded. Above all, public acceptance and adoption is also very important as far as autonomous cars are concerned. Driverless car cannot function ideally and get popularity without adoption across board. Now, if you see a nearby car, like what is shown in this cartoon, where they are telling there is nobody driving that green car. That's big news there. In future, if you look at that, hey, there is someone driving that car. There is a driver there. That is going to be the paradigm shift. So the conclusion of my talk is autonomous cars are going to be part of our life soon. Whether we like it or not, it is going to embrace us. 20 years before, where our grandparents used to tell this mobile phones and other things they cannot handle, now we can see that they are also handling with ease. So India is going to be a huge market for autonomous cars. Even foreign car manufacturing companies or vehicle manufacturing companies, they are looking at India as a potential market. Because when our country's economy is growing, naturally people will look for comfort. Someone who used a cycle may go for a scooter. Someone who had a two-wheeler, they will go for cars, and someone who have a conventional car will go for a little costly car. So what I need to convey is we must pick up, as engineers, we must pick up the right skills to contribute to the system requirements of the AI and IoT wave of autonomous cars. It can be in the architectural design, it can be in training your students, in building up small architectural domains that can model at least one small functionality of an autonomous cars. And rather than sending our students to only software and services sector, we can contribute to them to the core engineering. It's a wide open area. So if we are not filling up these slots in the automotive sector with the right set of computer and electronics and automotive then engineers, then some other people from the, because these companies has to grow, so they may hire talent from foreign pool, and especially China is going to supply this kind of a talent a lot. It's going to be Chinese professionals who will come and work here. So we need to contribute in architecture of them. We need to contribute in the algorithms required. We need to contribute in the programming. So India need good system designers, good communication architects, and design engineers to cater to the growing demand of skilled personnel in this domain. Over the COVID time, lot of developments have happened in the Union Ministry's thrust for Atmanirbhar Bharat. We started using more of locally developed products. And apart from petroleum, if you look at the statistics, after the import of petroleum, it is we spend most of our money in consumer electronics gadget import. Already India have realized India's own microprocessor, the Shakti microprocessor from IIT Madras. It has proved that it is completely indigenous microprocessor developed by the Intel. Sorry, developed by India. And even in automotive sector also, India is second to none. Many of our cars are popularly known. So if we have our right talent of electronics and computer science engineers stay back India or do research in this domain and contribute to this IoT as plus AI wave, where autonomous vehicles are going to be a very, very crucial sector, then for the next 10 years, these talents can make us proudly say that India can develop India's own cars that can run in India's own context. So I wish good luck to all the participants and wish that you could make India proud by your technical contributions, either as a teacher or as a teacher who can inspire students, who can pick up the right set of skills, who can contribute to the nation's growth. That's all from my side. I would like to open it up for the questions. And if at all you wanted to get back to me, you can contact in this mail address. So IIT Guwahati has an active research center who work in system design requirements for IoT, for hardware security, for network security, and architectural support for autonomous vehicles. We are open to PhD graduate candidates if at all you wanted to do PhD. We have internships programs for your students who can make use of summer and winter breaks to work with our research team. So IITs are national resource built with the taxpayers' money. So it is not only for the students who study in IIT, it is also equally applicable for those who wanted to associate with us. We'll be very happy to help them. So this is my email ID. You can drop a mail if at all you wish to connect with us or our research team. So that's all from my side. Over to you, to the coordinators, to coordinate the Q&A session.
Thank you, sir.
Good morning, sir.
Yes, good
Yes, you
morning.
can.
Yeah, I'm a participant. My name is Asha. I'm from BMS IT College, Bangalore, sir.
Okay, okay.
I'm working as an assistant professor. Thanks for the talk, sir. And I have I just wanted to ask you one thing. If we are really interested to make use of this IoT and implement a small project in autonomous vehicle, or even we know that we can do a lot of things in Industry 4.0.
Sound under sir.
Yes, go ahead, madam.
Yeah. So if we want to start a small project along with some set of groups, it can be in autonomous cars, or it can be something related to Industry 4.0. Especially, I'm interested in Industry 4.0. So can you just suggest, sir, how to start it? I mean, a small. My requirement here is that I want to have small contribution in software part as well as hardware. Are there any ideas to start with a small project with a group of some 3 to 4 students?
Okay. So thank you, madam, for the question. Can I know you are from computer science background or from electronics background?
I'm from electronics background, sir.
Okay. So the first and foremost thing is, if you wanted to look into the automation of these vehicles and all, we need to have an embedded system framework. I hope you will be working with the FPGA boards and all. So to
Yes,
start
sir.
with, you can have a small set of sensors that you can buy, sensors that can detect some parameters. It can be distance, or it can be temperature, or many other values. It can detect light. And based upon the sensors, then you can use small kits for the Raspberry Pi kind of boards, or you write programs into the FPGA boards and make use of smaller microcontroller plus interfacing. And then you can take one or two minor activity that an autonomous car will do. Let's say finding out an opaque object, finding out a color, red, green, blue color kind of thing. Or you can write programs which will embed into this microcontrollers, and with interfacing, you can do that. And every year,
Okay.
this SAE, so the worker automation. So in Pune, we have the Automotive Research and Institute. They conduct annual programs for the students, hackathon for the students. So you can develop these kind of minor working models and send
Okay.
them videos. Obviously, they will be then interested in further to collaborating. And the MeitY, Ministry of Electronics and IT, nowadays give generous funding for this startup, small startup kind of an ideas. And we have been members in many of the panels, which will fund many budding engineering students in this. So all what you need is some sensors plus FPGA boards, microcontroller interfacing, little bit of an LED, then LCD display connecting to this. Take one by one, smaller task, like what I so mentioned, and visit the. So I request you to go and find out like transactions on vehicular communication. It's a very good, reasonably good journal. It will give a lot of the research ideas as well. So that is a way how you can start up a small lab. Look for the next 3 or 4 years. Very small kind of a setup what in a normal college have. Try to have one or two good projects to be guided in this. And there are a lot of the NPTEL courses also which give some fundamentals about this AI and other aspect plus IoT and AI aspect. Look into this, get knowledge in this domain, and then try to approach some of the automobile giants, because they are all are looking for brighter talents. The problem with many of the electronics and computer science talents are going into IT sector or pure software sector or purely into computer science domain alone. So the other domain, especially the automobile sector, want good talented people. So they'll be very happy to shake hands with people who have shown some kind of a promising talent. So that is my
Okay.
input. If you wanted any further inputs, you can contact me. We will connect you with the appropriate people such that you can. So all you need is some passionate, hardworking students students who wanted to get a job other than the software field.
Yes, sir. Yes, sir. Yeah. Yes, sir. Thank you, sir. This is one thing, and similarly, something related to industry automation. I think even there are some opportunities for me even
Yeah.
to
Even in
look
industry
that.
automation also the concept is same. What they do, whatever they have done, whatever humans were doing, that was replaced with the help of machines, small robots and other things. So we require someone, see, the case of vehicle automation and industry automation is slightly different. In industry automation, little bit of robotics operations are required, generally, robotic arms and other things. So here also, it is basically sensing plus embedded system, but lot of activity, movement activity has been involved when it comes to industry automation. But ideally, the concept is same. Okay, so try to attend a few workshops in the robotics domain, which are being coordinated by premier then institutes. So that will give you a flavor. What are all the limitations and scope of robotics? And once you have passion into that, you can then integrate that as well.
Yes, sir. Thanks a lot, sir. Thank you very much for your inputs.
Hello, sir. Am I audible?
Yes.
Sir, this is Mohammad Junaid sir, from SVKM IoT Dule.
Okay.
Actually, that IoT is not, that IoT belongs to the Institute of Technology. That is not Internet of Things.
Okay.
So actually, I am from mechanical background.
Ah.
So having understood the significance and importance of these AI, OT, ML, all these domains, then I just realized that I should get the skills and knowledge of all these areas. Therefore, I just joined this FDP. With the
So you are a faculty member or a student, sir?
Actually, I'm faculty member from mechanical department, but still I have joined this because I just want to get the skills and knowledge of.
The inputs from the talk? Did you get any new inputs?
No.
Was it so useful to you?
Yes, sir. It was very useful, but only one point I am just afraid of. I can say is that I also need to understand a little bit about electrical circuitry also, because going through your presentation, there was some kind of chips and all that. So my question is that as a part of this IoT, should I also understand deeply about all electrical circuits and all sensors and chips and all that?
Okay. So thank you for the question. And first of all, I appreciate you in taking the risk in joining a program which is basically meant for electronics and computer science people, and still hoping that you will get some inputs. So our country want people like you who wanted to take such risk of 5 days spending time and see whether something is meant for you. So obviously, in a modern learning world, we cannot compartmentalize every product. This is a computer science product, this is an electronics product, this is a civil engineering product. It's going to be fusion of many branches. So what we need in future curriculums, where you have a say in designing the curriculum at some point, mechanical engineering students need to learn about microprocessors, about some amount of programming, about some amount of networks and communication than engineering. Similarly, computer science and electronic students should learn little bit of automobile than engineering as well. Then only this gap can be built. But in India, it's very difficult sometimes to change curriculum. So I have been part of various curriculum committees where many other parameters come into forefront when it comes to adding a new subject or dropping a subject. So there are a lot of online NPTEL courses available for people like you can easily take, like basics of networks, basics of microcontrollers, and these courses and many of these AICT, these FDP courses, like the NPTEL courses are also AICT approved FDPs. So that will be value adding to you as well. Try to attend these courses because nowadays after the online learning, lot many material is being generated. So this January, I think a new set of the NPTEL courses started. February also many set of courses are starting. I request you to find out the set of courses and they will tell prerequisite. Little bit of basics are required. And since material is available, learning all the things will hardly take 1 or 2 weeks. basic building, because ultimately you are an engineer. So you can learn the things, basic things in required in electronics within a week or so. So once you have the knowledge into that, with your strong background in mechanical and engineering, you would be able to give a lot of new insights to your students, because they always have a fear of touching electronics components. Once if the teacher lead by example, it will give a lot of confidence to your students that even learning non-mechanical engineering subjects would be much more value added in the future competition. So that is my my advice to you. Still, it's very easy nowadays. Material is available, and you can learn these things within a 1 or 2 months time.
Sir, another question is that during your presentation, you just told that for one autonomous vehicle, that will be equal to 2666 users.
Yeah.
That means one autonomous vehicle will use the data which is being used by 2666
No.
users. Right.
That is not like that. The amount of data generated by all these sensors fitted on an autonomous vehicle will be equal to data that is being browsed by roughly 2000, because it's huge amount of data. There are a lot of cameras, right?
Okay.
So it's as good as like
Correct,
you
correct.
have 50 CCTV cameras. So you need to
Correct.
have mechanisms by which, where will you store the data? This much 4000 GB of data per day. Where will you store? One hard disk is not enough. So how do you manage?
Okay,
So
okay.
you require again some kind of good approach, which will find out good data, bad data, future relevant data. That's what I was saying.
Okay, so actually the question is that all these data will be going to the clouds, right?
No. Should we store in the cloud? See, if everybody is
Yes,
having this
it will be
much cars
stored.
and 1 billion cars, cloud may
Yes.
not be sufficient, right? So what you need to store, what you need to discard is yet another important area. Not.
Okay, so for that, the data scientist will be
Data
required. A
scientist
lot
has
of
a
data
huge
scientists will
task,
be
and
required.
that has to be taken
Okay,
quickly. Quickly, I have to
okay,
decide: should I store the data? Should I
okay.
discard the data?
So the ultimate question is that suppose I just want to become a data scientist. So for that, will it be sufficient for me that I get the skills and all the required things for as a for the data scientist? And for that also, should I also understand all these electronics and electrical circuits
No,
to be under
data
to be?
science. No, data scientist may not require that much kind of background. All the thing is, wherever in future it's all about, wherever you find there is a gap in your knowledge, try to upgrade it with the available material. You cannot start a new field by learning everything. Some level of confidence you have, then the rest is your confidence that you can learn it on the fly. It's all about a passion,
Okay.
right?
Thank you.
Thank you, sir. Thank
Thank
you.
you.
Anybody else have any doubts to clarify? I hope nobody has any.
Hello.
Yes.
Good morning, sir. Sir, in which platform we did the implementation of these autonomous vehicle for research purpose?
No, in the research purpose, we are not designing a complete autonomous vehicle. No, we are taking a small component of autonomous vehicle. Let us say lane detection. Let us say warning when you change the gear. Can you continue in the same speed kind of thing? So in electronics, we require an embedded system wherein you store the programs in a microcontroller or an FPGA controller and then connect with sensors and actuators. So you require a basic FPGA where we can model this logic, and then it can be connected to appropriate sensors and actuators and display units. So it's basically a proof of concept what we do in academic research. And once you prove that this algorithm will work under these conditions, there will be lot many people from the automobile sector who will show interest in this domain.
Sir, any tools available, sir, like NS2, like other tools, any tool available for that implementation?
No, if you are looking for a vehicle macro level management, then the NS3 and other tools are required. But if That is required between vehicle-to-vehicle communication, management over cloud and all. But if you focus more on the sensing from the neighbors, then it is mostly into electronic side. You are learning with the help of sensors, write a Verilog program for the logic, and then generate the bit stream and put it into FPGA board, and then you test it in using the test bed. So there can be a system side, there can be an architecture side, there can be a device side. So it's 3 level. Depending on your expertise, you can concentrate on whatever level you want.
So actually, I am pursuing a PhD. My topic is not on autonomous vehicle, but on Internet of Vehicle.
Okay.
Security challenges on Internet vehicle. For that, I can start with NST. It will be okay.
Yes.
Okay.
That will do.
We have one question in the chat. Can you please mention the minimum configuration of FPGA needed for IoT applications? So do you want to take it?
Yeah. I will answer. See, it depends on. See, every FPGA board has some limitations on the number of IO pins. So depending on what is going to be your sensor, because the sensor is connected outside the FPGA board, depending on the number of sensors you wanted to connect, the number of bits the sensors are going to give, you can see it's basically it is not only about the configuration of FPGA boards, because it is more of interfacing. So the number of IO pins and the number of sensors you wanted to connect, that determines the FPGA capability. Because here we are not bothered about the speed at which you are. Can you grab in? Can you process? Can you generate output? That is what you are. So a basic configuration, Spartan boards and other things will work. You can look into the Intel's website and then find out various configurations required depending on your budget. If your college is generous enough to give fund, go for the best board. If you're thinking from your pocket, start.
Hello, sir. Good morning, sir.
Yes. Good
Sir,
morning.
sensors are capable of sensing temperature, all such things, but can it be possible to grasp the image of night vision, sir? Like clearly they can classify the object during the night, dark nights?
Yeah. So in completely, see, there are certain sensors which can detect the presence of opaque objects, something like what you use in radars. Okay. The other thing is for near locations, anyway, you are having the light with respect to the light, the illumination of the environment together with the camera will give you the effect. See, you are just trying to see whenever there is a plane that is traveling, whenever the ship is traveling through the sea, even in the night, they are able to capture, they are able to detect the opaque objects, detect the objections in between. So the same technology also they are using, but the presence of such kind of stoppages or blockings will be more. So you require algorithms which will work in illuminated background, whether natural illumination or artificial illumination, or you can have mechanisms which will detect objects, but I cannot get the shape of the object. For that, you require more streamlined kind of lasers.
Okay, thank you, sir. I think if there are more questions, please put in the chat box. I will share it with the professor and get the answers. So I want to thank Dr. John Jose for spending his valuable time sharing his insights into autonomous vehicles. And we could hear how autonomous vehicles, IoT, and even how computer architecture is related. So he has beautifully presented it to us. So I think it is of very great value to all the faculty members and research students who are attending this FDP. So on behalf of management and the Electronics and Communication Department of LBS College of Engineering, Kasaragod, we want to thank Dr. John Jose for sharing his valuable insight and into IoT and autonomous vehicles. Thank you, sir, for joining us. We hope to have continued interaction with you in the days to come.
Okay, so thank you, Ransi, and I have shared my mail ID. Someone asked in the chat box. So my mail ID is shared. If at all you wanted to communicate back to me, I'd be very happy. If by chance you didn't get a reply, try to ping me. So once again, if you are not getting reply, sometimes it out of busy schedule, I may miss mail, but normally I'll reply. So thank you for all the wonderful questions. I enjoyed being part of this session. I wish the program grand success, and it's good to see at least 120 participants actively there. So thanks to the organizers, and I wish good luck for all of you, and wishing that these kind of programs will really help the faculty community of the country to be up to date with the latest technologies. And special thanks to Dr. Mary Reena for the invite, for giving me a part of chance to be part of this FDP. Thank you all.
Thank you, sir.
Thank you, Rensi.
Okay, thank you
Thank
very
you,
much,
sir.
sir.
And once you get the feedback, kindly share it with me so that I will also know where to improve.
Sure, sir.
Sure, sir.
Okay. Thank you.
Thank you, sir. So, dear participants, we will start the next session at 11:45. Please join. You can take a break, maybe take a walk and come back at 11:45. We will continue with the next session on LoRaWAN for Internet of Things. Thank you.